Let's see if we can take the indefinite integral of cosine of x to the third power. And so I encourage you to pause the video and see if you can figure this out on your own. So you have given it a go, and you might have gotten stuck. Some of y'all might have been able to figure it out, but some of y'all might have gotten stuck. You're like, okay, cosine to the third power. Well, gee, if I only had a derivative of cosine here, if I had a negative sine of x or a sine of x here, maybe I could have used substitution. But how do I take the antiderivative of cosine of x to the third power? And the key here is to use some basic trigonometric identities. So what do I mean by that? Well, we know that sine squared x plus cosine squared x is equal to 1. Or if we subtract sine squared from both sides, we know that cosine squared x is equal to 1, let me write it this way, is equal to 1 minus sine squared x. So what would happen if cosine to the third power, that's cosine squared times cosine. So what happens if we were to take, what if we were to take that cosine squared? So let me just rewrite it. This is the same thing as cosine of x times cosine squared of x dx. What if we were to take this thing right over here? Let me do that magenta color. What if we were to take this right over here and replace it with this? And I know what you're thinking, Sal. What's that going to do for me? It feels like I'm making this integral even more convoluted. And what I would tell you, I would say this might seem like it's getting more complicated, but as you explore and you play with it, you'll see that this actually makes the integral more solvable. So let's try it out. So if we do that, this is going to be equal to the integral, the indefinite integral, cosine of x times 1 minus sine squared x dx. And so what is this going to be equal to? This is going to be equal to, let me do this in that green color. This is going to be equal to the indefinite integral of cosine x. I'm just going to distribute the cosine of x. Cosine of x minus cosine of x sine squared of x. Sine squared x, and then I can close the parentheses, dx. And this, of course, is going to be equal to the integral of cosine of x dx, and we know what that's going to be, minus the integral, I'll switch to one color now, of cosine x sine squared x. Sine squared x dx. Now, this is where it gets interesting. This part right over here is pretty straightforward. The antiderivative of cosine of x is just sine of x. So this right over here is going to be sine of x. And I'll worry about the plus c at the end, because both of these are going to have a plus c, so might as well just put one big plus c at the end. So that's sine of x. And then what do we have going on over here? Well, you might recognize, so I have a function of sine of x. I'm taking sine of x and I'm squaring it. And then I have sine of x's derivative right over here. So this fits I have some derivative of a function, and then I have another, and then I have I guess you say a function of that function. So g of f of x, and that's a sign that maybe use substitution is in order. Or we've seen the pattern, we've seen this show multiple times already, that you could just say, well, okay, if I'm a function of a function and I have that function's derivative, then essentially I can just take the antiderivative with respect to this function. So this would be equal to, if we say capital G is the antiderivative of lowercase d, capital G of f of x plus c. Now, if what I just said didn't make sense, then we could do use substitution and go through it a little bit more step by step. So let's just do that, because we want things to make sense. That's the whole point of these videos. So we could say u is equal to sine of x, and then du is going to be equal to cosine of x dx. And so this part and that part is going to be du, and then this is going to be u squared. So this is going to be minus, we have the integral of u squared du Well, what is this going to be? This is going to be, we're going to have negative u to the third power over 3. And then we know what u is. That u is equal to sine of x. So we have our sine of x here for the first part of the integral. So, or for the first integral. So we have the sine of x. And then this is going to be minus, let me just write it this way, minus 1/3. Minus 1/3. Instead of u to the third, we know u is sine of x. Sine of x to the third power. And then now we can throw that plus c there. And we're done. We've just evaluated that indefinite integral. And the key to it is to just play around a little bit with trigonometric identities so that you can get the integral to a point that you can use the reverse chain rule, or you could use u substitution, which is just really another way of expressing the reverse chain rule.